Hi everyone, welcome to Virtual Summit 2021. I'll be taking us through what's new in 2021.2 for InterSystems containers, specifically our IRIS, Web Gateway, and Arbiter products. My name is Phelps, and I've been a developer at InterSystems for just over 2 years now. I've been lucky enough to work on a few different product areas here, but my primary focus has been advancing our cloud technologies. I'm here to update you all on 2 exciting areas we've improved for 21.2. The security of our IRIS image, and the release of our new Web Gateway images. Then I'll switch over to a demo of how to use these images with the InterSystems Kubernetes operator, IKO. From this presentation, you'll learn how to upgrade to or start from scratch with our 2021.2 IRIS image, and you'll become familiar with our new Web Gateway images. For the sake of security, it's important for a container's processes to run as a non-root user. Yes, it's true that a container's root isn't nearly as privileged as the host's root user would be, but a container's root user can still do things you wouldn't want in a production environment, particularly if it's accessed by a malicious user. For example, changing the UID or GID, installing system packages, editing any part of the container file system it likes, binding privileged ports, the list goes on. If you're looking to deploy on a public or multi-tenant cloud environment, you or your security team are likely already looking for non-root solutions. Platforms like OpenShift, Red Hat's platform as a service for Kubernetes deployments, purposely makes it difficult to use containers whose processes require a root so that its deployments are more secure. Gitpod is another platform with similar restrictions. As the technology advances, this will just get more common. Our solution is to use a non-root installation of IRIS in our images. It's about as straightforward as it sounds. IRIS has offered a non-root installation for years, probably decades, in which the current non-root user is ultimately the owner of all IRIS files and processes. Historically, our first IRIS images, circa 2018, were installed and operated by root. Then at the end of 2019, we moved to the scheme you see on the left and are likely running today. IRIS was installed by root, but files and processes were owned by our predefined users, IRIS owner and IRIS user. This let us minimize the privilege for certain processes, but it's just incompatible with many security options that Kubernetes offers today, such as disallowing privilege escalation or defining exactly one user to own processes or file systems. I'll show you how you can enforce these settings when we get into the demo. For our 2021.2 solution, that non-root user is predefined as IRIS owner with the user ID 51773. It's important to note that the UID cannot be changed from 51773 since we explicitly switched to that user ID in our Docker files before installation. Given the user's permissions that are defined at IRIS's install time, which happens when the image is built, it isn't possible at this point to operate as a random UID at container runtime. This means that only IRIS owner can stop, start, or generally use IRIS. If you're any other user, including root, you'll get an invalid registry ownership error. The volume mounted for durable sys, that's our feature for persistent data storage in containers, if you're not familiar, must be writable by 51773 because IRIS won't be able to store data there if it's only writable by root or any other user. If you're planning to upgrade to an IRIS 2021.2 image, simply set 51773 as the owner of your durable sys directory for the older IRIS image and mount that directory with your new container. If you're using the InterSystems Kubernetes operator or InterSystems Cloud Manager, this step will be done for you. I'll cover an upgrade in my demo, so you can check it out for yourself. If any of this sounded familiar to you, that's because we announced our first non-root solution at Virtual Summit last year. It was released in 2021.1 as IRIS Lockdown. That image and its counterpart, IRIS Health Lockdown, will still be available in 2021.2 because it also has other features like an initial IRIS security of lockdown instead of normal, and a disabled management portal that users may be looking for. Outside of our IRIS products, we will also release non-root Web Gateway and Arbiter images. The non-root Web Gateway is named Web Gateway Lockdown. The takeaway here is that starting with our 2021.2 release, you can deploy a cluster of IRIS, Web Gateway, and Arbiter products that's fully non-root. The second part of this presentation is particularly exciting to me as someone who tried to deploy the Web Gateway container before we updated it. For those who haven't used it before, our Web Gateway product serves requests to REST services defined in IRIS. Before our 2021.1 release, the kit was fully supported, but the container image for this product was only compatible with ICM, the InterSystems Cloud Manager, not Kubernetes or any other container deployments. For 2021.1, we've rewritten the entry point to take a handful of optional inputs, including the 3 environment variables listed here. Just like IRIS, you can specify ISC data directory and mount that path on a volume to persist data beyond the container's lifecycle. In the Web Gateway's case, this includes its config files, csp.ini and csp.conf, as well as the Web Gateway and Apache logs. The Web Gateway image comes with default configuration files, but they can both be overwritten if you use the environment variables isc.csp.ini file and isc.csp.conf file. csp.ini includes Web Gateway-specific configuration, like the connections to IRIS instances, and csp.conf covers settings specific to the web server. In this case, our Web Gateway uses Apache. With our 2021.2 release, we're going even further. We'll have 2 Apache-based Web Gateway images, one owned by root and Web Gateway Lockdown, which is non-root, and owned by our IRIS owner user. Plus, we're releasing a root-owned Nginx-based image. All of these images can be configured at startup with the settings I outlined on the last slide and are supported by IKO and ICM and will be seamless to use in your manual deployments as well. So, if you're in a container environment, it's time to check out the Web Gateway. Now let's take a look at how you deploy these images in Kubernetes with IKO, the InterSystems Kubernetes operator.
In this demo, I'll be using our InterSystems Kubernetes operator on the Google Kubernetes engine to deploy IRIS and Web Gateway instances. Breaking down the windows you see in front of you, I'll be using the top terminal window to monitor the health of the cluster, the bottom right to apply changes, and the text editor on the left to show you configuration details. I created this cluster with the command you see at the top, which requests a cluster in region US East 1 with 1 node in each of the node locations, US East 1B, US East 1C, and US East 1D. To get started with IRIS with Kubernetes, though, the first thing you'll want to do is deploy IKO, the InterSystems Kubernetes operator, after you have your cloud cluster up and running. To do that, you download the tar from our distribution page and Helm install. And then we can watch this pod come up in just a few seconds. Next up is deploying IRIS. On the left, I've written YAML that specifies a sharded cluster with 3 data nodes using our IRIS 2021.1 release. It also has an external load balancer that we can use to access our system management portal. If you weren't using IKO, you could write YAML to the same effect with an extra 100 lines or so, but here we can manage it with just over 20. You can tell this was written for an IKO deployment because the kind at the top is IRIS cluster. Vanilla Kubernetes doesn't support IRIS clusters. Before applying this YAML, I need to create 2 artifacts that I reference here, IRIS key and IRIS CPF. Those are exactly what they sound like, my license for my IRIS instances and the CPF merge file. My CPF merge file is very basic, it just has the password hash that I want to use for all my IRIS instances. IKO will generate much of the configuration you'd want for deployments, like sharding and mirroring settings, for example. Now I can initialize my IRIS cluster since I have those 2 artifacts. You can follow along as these instances come up in the upper terminal. IKO staggers deployment so that shards come up and join the cluster one after another. As IRIS starts up and configures itself, you'll see the ready state become 1/1. Since I requested a load balancer down in the service spec, I'll have a public IP that I can use to access the management portal. Down here. So copying this IP. We can see it's pointing to my data 0 node, as we expected. If you were mirroring, this service would follow the primary as instances fail over. But in this case, it'll just point at the sharding master. So this is our IRIS 2021.1 release. If you wanted to upgrade to our IRIS 2021.2 release, which is non-root, you'd have two steps. Upgrade IKO, then upgrade the IRIS image in your cluster. Upgrading IKO is a Helm upgrade command. Download the new IKO tar from our distribution and run a command like this. Then apply another IRIS cluster YAML that updates the original deployment. Oh, and if you try to apply it before the other one's up and running, you'll get that error. But here we go. So this second YAML that I applied is just over here. And it's a little longer, but basically the same as our first YAML. So I updated the images to point to IRIS 2021.2, and I also added the security context setting section. So this section is completely optional. It just demonstrates the extra restrictions that you can apply starting 2021.2. So here I'm enforcing that we run as a non-root user, specifically user 51773, and the file system group is also 51773. When these upgrades are applied, Kubernetes manages bringing up the new pods and terminating the old ones. IKO takes care of changing file permissions so they're compatible with the non-root instance. IKO also takes care of any extra configuration it needs, like taking shards 3 into 3 actually configured IRIS instances. So you can see one by one, each of the demo data 1, 2, and 0 nodes were terminated one after the other and now are being brought back up. Now that everybody's back up and running, we can exec into one of our containers and check our IRIS $ZV to see that the version is updated as we expected. And there we go, we're up to IRIS 2021.2. Now let's add a web gateway node. That I can add with just one small section in the YAML. By the way, in each of these cases, I could have edited the existing file instead of replicating it, but the IRIS cluster is just uniquely identified by this name in the metadata. So here with this new file, it's almost identical to the previous one, except I've added this 4 or 5 line section down here for the web gateway. So I'm specifying that I'm going to use the 2021.2 web gateway image, and this is just the Apache version. It's not Apache Lockdown or Nginx. And I'll only ask for one of these. If you're already a web gateway expert, down here you can do application paths or alternative servers, but we can just configure those settings through the management pages in a moment, which I'll walk you through. And we can see it doesn't affect any of the IRIS instances. It just adds this web gateway node. IKO will deploy an external load balancer for the web gateway nodes as well. So we can use that external IP to access its management pages. In this configuration, I just used the regular Apache Web Gateway image. I didn't use Apache Lockdown. So it's probably reasonable to expect that users would want the same security settings for all containers in their pods. But you're not restricted in any way. So you can mix and match as much as you want. And you'll see basically the same UI if you're doing Nginx or Apache, and basically identical if you're doing Apache Lockdown. Out of the box, IKO configures a framework of what it expects your web gateway configuration to look like. So for example, since we have 3 shards, it'll define a server for each of those. For example, here, maybe I want to use, in my actual deployment, maybe I want all my traffic to go through CSP system instead of _ system. So I would put in the credentials for that user. And scrolling down here, if I wanted to go through the TLS configuration, I would do that here. Any minimum, maximum server connections, save configuration. Under application access, there's just the default 2 application paths here, but you could add or edit these as you please, defining like which servers they should use, etc. And there's also parameters for the web gateway itself, like you can see restrict which IPs can access the management pages. You can change the password for the management pages themselves, maximum number of connections. All of these parameters that I've just showed you are hosted under the same csp.ini config file. And while you could deploy a mostly blank configuration and customize it manually, you can also take the configuration that's generated from me going through these steps and apply that for all future deployments. So here, all I've changed so far is changing the username for this demo data 0. So I'm going to grab the csp.ini file from this deployment, wipe out this instance and all of its persistent volumes, and then we can see how these changes take effect in the new instance when I redeploy it. So here, this is the durable volume for the web gateway. It's got csp.conf, ini. csp.conf just isn't particularly relevant here. It's just Apache configurations, which I'm not messing with here, but maybe you will, in which case you'll want to mount that as well. And then the log file and csp.load. So here what I'm interested in is the csp.ini that was modified. And some of this is also what IKO generated itself, which may be interesting to grab. So I'm just going to copy this, make a new file. And then I need to add it to a config map. I'll just add it to IRIS CPF, the one I have before, just to make things a little easier. And first I'll scale down. So I'm just going to change replicas to 0 and apply this. So you'll see the web gateway terminating at the top. And then I'll modify the config map. So here I'm just going to put 2 files in the config map instead of just 1. So I'm including the CPF merge file from before as well. So now we have this config map, and now let's delete all traces of the web gateway that we just killed. So I'm going to delete its persistent volume claim. This config map I just deleted is generated by IKO, so you can look at it if you're curious, but you won't need to touch it. Delete that web gateway service. And now I'll scale back up. I don't need to specify anything about the new config map because it's already specified here at the top. And now we'll see our web gateway scaling back up. Our web gateway node is back, so let's check on the service. And the only setting we changed here that would be that noticeable, we go to data 0, we can see that the username here is now CSP system when it's by default, and in all the other configurations, _system. But this strategy of doing the configuration in the very handy UI and then taking that outputted config file to use for all of your deployments will work for any of the web gateways, and then you can use that same csp.ini across multiple. So you don't have to change your csp.ini configuration if you're moving from the Apache-based to the Nginx-based web gateways. You would only need to change the csp.conf file because that's what's specific to Apache or Nginx. If you are going to switch from Apache to Nginx or Apache to Apache Lockdown, etc., you would have to scale down and delete all PVC services, config maps, etc., just like I just did for applying the configuration though, since deploying those images is different. But that just comes down to the type parameter here. And there we go. So if you have IRIS 2021.1 deployed with IKO, you have a very straightforward upgrade path just by upgrading IKO first and then upgrading IRIS. So don't let the non-root IRIS image scare you. And I hope you check out the new web gateway images too.
Cloud is a particularly hot topic this summit, so if you're interested in learning more, there's plenty of sessions to keep you busy. These are some of the ones I'm excited about, which cover what's new in IKO, high availability cloud solutions, and our new software as a service offerings. For security folks, I'd recommend DPSec1 to learn about the new security database. If you have any questions, feel free to send me an email or reach out on LinkedIn. Thanks, and have a great virtual summit.